Welcome back to the channel. So today's question is create binary tree from description. So in this question we have to create a binary tree as mentioned in the question or in the description. It is just a simulation of the problem. So the problem states that you have given a description and it has given that parents, children and is left. So we have to create a tree from this value. We have to build up a children, a parent and a children, then place it on the left or the right side based on the question. So let's say the intuition behind is we have to track the building nodes. That I'm gonna show you with an example that will make a clearly understanding for you. Let's try run with an example. So I have given the description says that 20 is the parent and 15 its child and it is on the left side as the value of left is 1. Now go with 20. Again 20's children is 17 which is placed on the right side. 0 means right and 1 means left. Okay, now 50 is the parent of 20 and 20 is placed on the left side. Again 50 is the parent and its children is 80 which is placed on the right side, and 80 is on the left side and 19 is on the left of the 80. So that's how we are gonna build the tree. But here you can see that we do not understand how we are gonna find the root node, and there is nothing tricky about building up this. Later on I will tell you how you can find the root node, but I will gonna make you understand one thing very clearly. We are gonna recreate this with a different approach. Let's say we are gonna perform this description first, then this is second description for building a root node, then this is fourth, then this is fourth, oh that was third, and this is fifth. Now recreate this. So 20 is the parent, its children is 15, 20 is the parent, 17 is its children. Now we are going to perform this, which is going to say that 50 is the parent and its children is 80 on the right side. Now 80 is the parent and 19 is gonna on the left side. Now let's perform the fifth step, which is gonna say 50 has a children 20. Now we have created a new 20, but that's not the way of solving the question. When we are creating the new node 20, so there is no connection between this whole two trees. So that means they both become two individual tree, which is not required in the question. We have to create a single binary tree. So here we have to track this with the 50. So this 20 should be attached with this 50 on its left side. How we are gonna achieve this? So achieving this, we are clearly understanding that we should have the storage where we can put our nodes, which we have created already. All the created nodes should be put inside the map. Suppose we have already put this 20 with the value 20 and created a 20 pointer for it. So when we are gonna ask for the fifth step says that we are gonna find 20. So we can get 20 easy from the map, and we are gonna put this 20 over here, 20 pointer, which is gonna point to this value. So how we are gonna achieve that? I'm gonna try run with the same example again. Let's recreate it with the help of a map. 20. So 20 comes first. So we are gonna put it inside the map with its pointer value. Now 15 arrives. We place 15 to its left. Now 17 came again. So for 17 we are gonna put it on the left side, and we are gonna also building up that to 15 and the 15 pointer. The thing which is gonna arriving first, we are gonna make a note of them and put them into the map. Now it's term for the, if I'm gonna try run with this, so 50 come first is a parent and the 80 is the children on the right side. and we will gonna see that 50 is not present, so create a new 50 on the map with its pointer value, and same goes with 80. Just create and put it on the pointer value. Now 18 with 19 arrives first, so place it inside the map. Now you are gonna see one thing. We are gonna perform fifth step, which says 50's children is 20, so we are gonna for 20 in the map. 20 is present in the map. We got its pointer value and placed it on the left side of the 50, which clearly this pointer points to this tree, so we finally got our tree. Let me create it clearly for you. So this is our final tree, and this all the value we are going to store in the map. So now you can see that we have tracked all the values with their pointer values in the map, and we have created a tree. So now the one thing which is most important, how we are gonna find the node, which is the root node. That's the main thing to be think about it. We do not track the root node. So let me show you with a clear example. So now the main challenge is how we are gonna find the root node. As you can see that a root node, if suppose this is a root node, it should have the left child and the right child, but it cannot be the children of any other root. If suppose there is R present over here, so R do not have the children root, because then R become the root. So we do not require R as the root, we require root as the root. So for that we have to find in this tree the one who is not the children of any other node is the parent. As you can see that 15 is the children of 20, 17 is the children of 20, 20 is the children of 50, 19 is the children of 80, 80 is the children of 50, but 50 is the alone who is not a children of anyone, so it is the parent. How we are gonna see them, how we gonna find it? So this is our description. Let's clearly see the description and observe it briefly. As we know that in the first step 15 is a children, so we are gonna go in the map and we are gonna erase 50 from the map because it is already a children, so it cannot never become a parent node. Now see the step 2, 17 became the children, so we will remove it from the map. Goes for the step 3rd, 20 is removed because it become the children. Same goes with the 80 become the children. Now goes in 19 become the children, and in the end you can see clearly in the end the one who is left is the parent of the root of the map. So in the end we are going to return this from the map, which is our final answer, which is our final root node. Now moving towards the code part, how we are going to build up the code. Let's move towards the code part. So I have created a map which is going to store the parent and the children's nodes value. Now this root is going to help us to track the parent's value. This root is not the final root. Final root came from the maps from the map, which is the final value stored in the map. So I have created a parent value from the description, children from the description, and is left from the description. If parent is already present in the map, so we are gonna track it on the root. Just I told you before, root is gonna track the value for parent nodes. So we got the current parent's root, current parent's value, and we are gonna check the same from the children. If children is already present in the map, I have make a pointer children and get its value from the map, and I'm gonna check the direction, in which direction we are gonna place the children. If left is true, we are gonna attach on the root's left side, otherwise I am gonna attach in the root's right side. Now the same goes with this. If the children is not present, we are gonna create a new node of the children value, of the child value, and we will store that into the map. And for this direction code, now move towards how we are going to think of the if it is not present in, if the parent is not present in the map. If parent is not present in the map, we are gonna do simple thing. Just created a new node for the parent and track it down into the map, and we will check if the children is present in the map. If it is not, if it is already present, take it from the map. If it is not present, then created a route for it, check its direction, place it based on this direction. Goes similarly with this, check its direction and place on the basis of its direction either the left side or the right side of the node. Now the route finding logic is simple and clear. Just iterate over the description and remove all the children from the map, and at the end return the map's value. So that's the way of solving the question. Now move towards the time and space complexity. In the time and space complexity, let's see the time complexity. As we are iterating over the description and we are on the run, we are gonna building the root nodes and attaching it with the parents node. So we are going to perform big of an operation, as we are not iterating back in the description. So it is a straightforward approach. Just move in the description and build up the root. So it's a big of an operation, and we are using a map which stores all the value inside the map, which is gonna take big of an space complexity. And the time and space complexity both are same, both are big of n. So that's the solution of solving the question. The main thinking of solving the question is that you have to just track down the nodes values, and the second thing to be mentioned in the question, which is to be think about, is you have to know how you are gonna find the root node, which is clearly itself says that it do not have any children. So remove all the children from the map, and the final value is the root node. Return it as the answer, and you got the solution clearly. Thank you for watching this question. The code is in the description link. You can check it out there. Like, share and subscribe.